Hi everyone, and welcome to Module 3, Part 2. So we're still going to be talking about confidence intervals. We're just going to look at what happens when they actually give us the population standard deviation. How do we compute that then? Okay, so we have two objectives today: to define and calculate a confidence interval, and to determine the sample size needed to achieve a certain margin of error. So we're going to do a little review first. So the first review is I want to match the variable with what it represents. So I want you, if you're at home taking these notes, I want you to go ahead and do this on your own. So go ahead, pause the video, and then come back and check your answers. Welcome back. Let's see how you did. So N is my sample size. Number 2, so that's X bar. X bar is going to be your sample mean. 3 is sigma. Sigma is your population standard deviation. 4 is mu. Mu is your population mean. And the last one, 5, is S, and S is my sample standard deviation. So hopefully you did well on that. Again, it's really important that you know which variable goes with what. Okay, so just a little bit more review from Module 3, Part 1. Confidence intervals give us a range of possible values for the population parameter given a point estimate. So how you calculate that confidence interval, it's your sample mean plus or minus your margin of error. Again, the margin of error is calculated by taking the critical value and multiplying it by the standard error of the statistic. And that standard error of the statistic is your sample standard deviation divided by the square root of n, and n is your sample size. How to calculate the critical value depends on whether or not we are given the population standard deviation. So if the population standard deviation is known, we will use a z-score. So we haven't seen that yet, but you will see that today. And if the population standard deviation is unknown, we use the t-statistic. So that's what we did in Module 3, Part 1. We did not know the population standard deviation, so we were using that t-statistic. So when sigma is unknown, to find the margin of error, so again, this is just a review. You take that critical value, you times it by the sample standard deviation, and divide it by the square root of your sample size. Just remembering your degrees of freedom, it's your sample size minus 1. And to calculate the t-statistic, you're going to plug this into Excel. So we have a review example. So again, since this is a review example, I want you to do this on your own. Pause the video, go into your Excel spreadsheet that I had posted. It's going to be on the same one as that you did Part 1 on. It's just called Part 2 Example 1. And I want you to go ahead and fill it out and then come back and check with me. Okay, welcome back everyone. Let's see how we did on this review example. So the question is, suppose we want to estimate the average weight of an adult male in Georgia. We draw a random sample of 1,000 men from a population of 1 million men and weigh them. We find that the average man in our sample weighs 180 pounds and the standard deviation is 30. What is the 90% confidence interval? Okay, so I'm just going to go ahead and fill in some stuff. So just kind of going what we normally did. N is your sample. So we have 1,000 men. My degrees of freedom, remember that is equals my, remember to cell reference here. So I touched the D8 because that's where my N is, minus 1. Oops, and I forgot to hit enter. Okay. Next thing I'm going to do is, and again, some of these things you could fill in. So S is going to be my sample standard deviation. We know that that is 30, so I'm going to go ahead and fill that in. And then my X bar, that is my average of the sample. So again, that was 180 that was given to us. So those things are fine to just plug in the numbers because that's information that's given to us. Everything else we're going to use cell referencing and an equation. Okay, so let's go ahead and find alpha. So if you remember, your alpha is 1 minus, okay, and then I'm going to go, it's a 90% confidence. So I'm going to do 90 divided by 100. I go ahead and enter, so I get 0.1. So now I'm going to go ahead and find that critical value. So remember your critical value, that's that. I'm using my T inverse. There it is. So my probability is my alpha. Then I'm going to click the degrees of freedom. Okay, and then hit enter. Now I can go ahead and find my margin of error. So remember your margin of error, that's going to be your critical value times my sample standard deviation divided by the square root of your sample size. Okay, so now I have my margin of error. Now I can go ahead and find my upper and lower bound. So remember your lower bound, you're going to take your sample mean and you are going to subtract your margin of error. And then to get my upper bound, I'm going to take my sample mean and add my margin of error. So then if I was interpreting this, we are 90% confident that the limits of 178.44 and 181.56 contain the value of the population mean mu. So hopefully you did well on that. Okay, so let's do another example. I'm going to go over here. This one's a little bit different though. So this time we're not given our sample mean and we're not given our sample standard deviation, but we are given the data so we can find it. So that's going to be a nice review from Module 1, Part 2. So let's read the question. So listed below are weights of randomly selected girls at birth from the data of National Center for Health Statistics. Use the sample data to construct a 95% and 99% confident interval for the mean birth weight of girls. So let's go ahead and start with 95. So N is our sample size. Again, it's not given, so all I did is I counted how many, and then I had 15. Okay, so I'm going to go ahead and do my degrees of freedom. So that's equal to N. Whoops. Sometimes it is a little bit more picky. Okay, let me just go back. Okay, so equals N minus 1. Okay. And let's go ahead and fill in our alpha. Okay, so that's 1 minus, so we want 95% for this one, so 95 divided by 100. Whoop, and if you notice, I forgot to put my equals. So sometimes that happens. 1 minus, okay. So now, I'm going to fill in these next two things because we're going to end up needing our standard deviation and our X bar to answer our critical value and our margin of error. So to remember, I'm going to go ahead and here. So my X bar, okay, that is just the mean. So that's my average. So again, I'm going to hit equals and then I'm going to type in average, if I can spell, average, okay. And then mine's a little bit picky, so I'm going to go really slow. There, whoop. There we go. Oop, dang it. Nope. Okay, so I need to fix mine. Did not get the last one. Okay. So this is the one downside to an iPad is it just is really there we go. Okay, so there we got our average. Okay, so now I'm going to go ahead and do my standard deviation. Okay, so again, equals Okay, so then remember with the standard deviation, you want to use the sample. Okay, so again, I'm going to go here and I'm just going to go really slow. There we go. Okay, so now I have my sample standard deviation. Okay, so now let's go ahead and compute everything. So your critical value, so again, that is equal to my, I got to go into T. Sometimes you get so many equations in your head. You get one step ahead of yourself. Okay, so then alpha, then my degrees, alpha, and then my degrees of freedom, hit enter. Okay, so I have my critical value. Now I can find my margin of error. So this is equal to my critical value times my sample standard deviation divided by the square root of my sample size. Okay, and now I can go ahead and do my upper and lower bound. So remember your lower bound, again, that is your mean minus your margin of error, and your upper bound is your mean plus your margin of error. Okay, so then answering that question, we are 95% confident that the limits of 29.25 and 32.49 contain the value of the population mu. Okay, so the next example in your notes, it's the same problem. It's just the only difference is I want to do a 99% confidence interval. So one thing I'm going to do, and I reshot part example 2 in module 3 just to show you how you can copy over data so you don't have to redo every equation again. Okay, so let's look what's the same here. So just to practice, I know we could type in 15, but I'm going to practice doing this because in the next week's module, you'll want to know how to do this. Okay, so I just hit equals, and then I click the cell I want to copy. So equals, cell I want to copy, and because I don't want to do all this work again, so I'm going to copy over the stuff that is going to be the same for both. Okay, so those are the things that are going to be the same. Now we have a different alpha, so I am going to go ahead and recopy that. So that's equal to 1 minus, this time we want to do 99%. Okay, now I can go ahead and calculate this. So equals T. So this is just really good practice here. So my probability is my alpha, my degrees of freedom. Okay, and then my error bound, okay, so equals my critical value times the sample standard deviation divided by the square root of my sample size, okay, and then my lower bound, okay, again, it is minus my error, and then the upper is you add it. Okay. So you can tell with that, it was really handy that I didn't have to, especially doing the mean and the standard deviation, I didn't have to redo that equation. I had already done it. So I could just copy that information over because it stayed the same. The alpha didn't stay the same, therefore the rest of my data didn't stay the same, so that's why I didn't copy that. But if it's the same, I just went ahead and copied it. So to answer the question then, we are 99% confident that the limits of 28.62 and 33.11 contain the value of the population mean mu. Okay, so let's go back to our notes. So those were some great examples. So let's go here. So the width of the confidence intervals. So that does mean something. The higher the confidence level, the wider the interval. Okay, so for example, a 99% confidence interval would be wider than a 95% confidence interval because we have to be more confident that our population parameter is contained within those bounds. Okay, so if you're looking here, these confidence intervals, if we want to be 90% confident, my margin of error is 1.48. 95 is 1.76, 99 is 2.31. So if you notice, that margin of error is growing because we want to be more confident that it's contained in there. Okay, so your margin of error becomes smaller if your z-value is smaller, your sigma is smaller, so that's standard deviation, and your n is larger, so we have a bigger sample size. So what happens if we know our population standard deviation? So what we're going to do is, again, if your sigma is known, for this type of problem, we switch from a t-statistic to a z-score. Okay, so we talking about going from a normal to a standard normal in Module 2, but we won't have to do all that work for it, and I'll show you in just a second. So when your sigma is known, we use the following method to calculate the margin of error. So it looks pretty similar here, okay, except instead of your t-score, you notice that you're using your z-score. Okay, and again, it's instead of the sample standard deviation, you're using the population standard deviation, but it's still divided by the square root of your sample size. Okay, so like I was kind of talking about before, we could use our norm dot inverse to calculate our z-values, but the problem with that is we don't have the sample size into consideration. There are no degrees of freedom. We can just pull it from a chart. So this chart here, and I'm going in yellow so you can really see it, make sure you have this with you at all times because you're going to need this chart. Okay, so we will be referencing this chart here. And to be honest, some of these values should look familiar from Module 2 because we did end up seeing those quite a bit. Okay, so determining sample size. So what happens, so we're not going to be necessarily given our sample size. So how do I know if I want to be like 95% confident and I'm doing research, how many people do I need to sample in order for that to happen? So this is what we're going to talk about here. So if we want to collect a sample to be used for estimating a population mean, how many sample values do we need? Well, to calculate the required sample size, we're going to need this equation right here. So again, another important equation that we're going to need to use. So you have your z-score. And remember, your z-score we're just getting from that table times your population standard deviation divided by your margin of error, and then we square that answer. Kind of a lot, but we got it. Okay, so we're going to now look at 2 examples. So again, I'm going to want to go ahead and go to my examples. Okay, so here we are. We're going to go to sample size examples. So here's our last 2 that we're going to do. Okay, so assume that we want to know or want to estimate the mean IQ score for the population of statistics students. How many statistics students must be randomly selected for IQ tests if we want 95% confidence that the sample mean is within 3 IQ points of the population mean, and we know the population standard deviation is 5 IQ points. Okay, so let's see what we can fill in. Okay, well remember sigma, well let's just start at the top. So my z-value, I want a 95% confidence. So what I'm going to do is I'm just going to go look at this chart. 95% confidence level gives me a z-value of 1.96. So that's what I'm going to enter here. So I have 1.96. Okay, now my sigma, again, that means that is my population standard deviation. So I know that that is 5. So I'm going to go ahead and type in 5. Okay, my margin of error. So here it tells us, okay, that we want the sample mean within 3 IQ points of the population mean. So that tells me my margin of error. Okay, and now we can go ahead and find our sample size. So again, I'm using this equation that right over here to the right. So now let's type it in. So it's equal. Now because we have to square it, I have to put this parenthesis first. Okay, so I'm going to do, it's my z-score times my standard deviation, okay, divided by my margin of error, and then I'm going to square it, so I'm going to close those parentheses, okay, because order of operation matters, and then I'm going to click the little, let's see here, it's a little bit harder to find on mine, the little caret, here it is, there we go, and squared, and enter. Okay, so then our sample size, okay, so this says 10.67 would be our sample size, so I would want 11 to be able, because 10 would not be enough to sample. So I'd want to round up to 11, because obviously you can't have 10.67 of a person. Okay, so let's go to the next example. A tax assessor wants to assess the mean property tax bill for all homeowners in Madison, Wisconsin. A survey 10 years ago got a mean of 1,400 and a standard deviation of 1,000. How many tax records should be sampled for a 95% confidence interval to have a margin of error of 100? Okay, so let's think what we can fill in. So it's 95% confidence interval. Again, you go reference a chart, but we did have a 95% confidence interval for 7, so I can just look at that and know that that is 1.96. Okay, my sigma in this case, so what is my standard deviation? My standard deviation is 1,000. Okay, my margin of error, so they want us to have a margin of error of 100. Okay, and now I can find how many I need. So how many tax records should I collect? Okay, so let's go ahead and use that equation. So it equals, and again, I'm using this equation right over here in the yellow box. Okay, make sure, because we're going to square it, put that parenthesis, so it is this times your sigma divided by your margin of error, close those parentheses, and then I square my answer, and I have my answer. So I get 384.16. Okay, so again, I would need 385 at least. Okay, so that is it for this. So just to summarize, confidence intervals have a different critical value depending on if the population standard deviation is known or not. If the population standard deviation is known, we use the z-score, and if it's unknown, we want to use the t-statistic. When trying to find the required sample size for a particular margin of error, we use the following formula. Okay, so again, that's your z-score times your population standard deviation divided by your margin of error, and you square that answer. Okay, if you have any questions, please come join me in the live classroom or send me an email. Have a